Okay, this is number 11 on page 287. Okay, so the question says the number 5,880 can be factored into prime divisors as 2 times 2 times 2 times 3 times 5 times 7 times 7. So what does that mean? Well, the first thing, maybe just a little number theory discussion. Basically what we're saying is this is equal to this. So the number 2 times 2 times. So you can verify that if you want. And what prime divisors mean is notice these numbers are all prime. So if you don't know what a prime number is a whole number, let's say a natural number, only divisible by the number 1 and itself. And it's a fact that any number you can write can be written as a product of prime numbers. So like this, obviously different primes. Okay, so notice that if you can write 5,880 as 2 times 2 as this, then 580 must be divisible by all these numbers, right? 580 is divisible by 2, it's divisible by 3, it's divisible by 5, it's divisible by 7. If you're not sure of that, you can check that, but that should make sense if you can write it like this. But it's also a fact that any number that divides any other number, but we'll say 5,880, is a product of its prime factors. So meaning, numbers that, if you just took some of these prime factors, then they'll divide 5,880. So for example, I could take 2 times 2. So 2 times 2. I took the first 2. That's equal to 4. That means 4 divides 5,880. And you can verify that for yourself. I could take 2, let's say I take this one, and this one. So 2 times 2 times 3. 2 times 2 times 3. So that's equal to 12. Well, that'll divide 500. I could take, let's take a 2, a 3, and a 7. So 2 times 3 times 7. Okay, so that's 42. And that will again divide 5,880. And any set, right? You could take 5 of them. Like I could take the 2, let's take 2 2s, right? I got 1, 2, a 3, a 5, and a 7. Times 3 times 5 times 7. That's a pretty big number, but it should divide 5,880. I believe that's 420. So that one will divide 5,880. And you can verify that. Just use your calculator. That number will divide 5,880. So any set of these numbers multiplied together will divide 5,880. So to answer this question, A. So determine the total number of divisors of 5,880. Well, what we just said is any divisor of 5,880 will be the product of some of these numbers, like some group. So we could say a subset of these numbers. The product of the numbers a subset of all the divisors. So 2, 2, 2, 3, 5, 7, 7. So all you need to do is determine how many subsets there are of this set. But notice these are all the same, and these two are the same. So you wouldn't actually write those as a subset. So what we're going to do is count the subset where you have some identical items. So remember, that's where you're going to say, okay, action 1 is selecting how many 2's we should take. So since there are 3 2's, we have 4 options. The 4 options are 1 2, 2 2's, 3 2's, or no 2's. Times, then for 3, you have 2 options. Use the 3 or don't use the 3. Times 2 options for 5. Use the 5 or don't use the 5. Sorry. Times, now 3 options for 7. Use the 7 or don't use the 7. And now you're going to have to multiply these. One question you might ask is, do we subtract 1? Do we want to include the null set? And in this case, we will not we will include the null set, because the null set would be like taking none of these, but you'd still have like a 1. Meaning, since the number 1 divides 5,880, we don't subtract 1. So you could think of, that null set case as being the number 1. So we don't want to subtract that extra case out. So 4 times 2 times 2 times 3. It gives us 48. So therefore, there are 48 divisors. Okay. In this one, how many divisors are even? So even. So how do we determine even divisors? So what's special about even numbers? An even number is divisible by 2. That's kind of what makes an even number an even number. It's a multiple of 2, or it's divisible by 2. So what that means is you have to include a 2 in sort of this subset. So this means we must include a 2. So back to here, when you're deciding on how many 2's to use, you now don't have 4 options. You're now down to 3 options. 3 options because you can include 1 2, 2 2's, or 3 2's, but you're no longer allowed to include 0 2's. So must be at least 1 2. Times, and then it doesn't change for the rest. Still, you could have 1 3 or no 3's. Still, you could have, you have 2 possibilities for 3, 2 possibilities for 5, and 3 possibilities for 7. So you're just going to multiply all these numbers and get, 36. So therefore, there are 36 even divisors. Okay, and then part C. Well, part C is odd. So there's 2 ways to do odd. You can kind of go indirect and just subtract the total number of divisors minus the even divisors. and that should give you the odd divisors. We'll say number of. So what was the total number? Total number of divisors was 48. So you had 48 total divisors minus 36 even divisors equals 12 odd divisors. So therefore, there are 12 odd divisors. Another way to do this question would be to go not by the indirect method. So just looking at, where were we? Oh, back to the subset. So looking at all the divisors again, remember if it's going to be odd, you don't want any 2's, right? We don't want to select a 2, so there's really only one option. I'll do it right here. So there's one option for the number of 2's, right? And that option is don't pick a 2. How many options are there for the 3's? So for the 3's, you have 2 options. Pick a 3 or don't pick a 3. For the 5, again, 2 options, times, and then I think the 7, there was 2 7's, so you have 3 options. So 2 times 2 times 3, 12. So therefore, there are 12 odd divisors, which, looking back, was the same number we had down there. So we're good.